Okay, laws of sines is going to be our lesson today, but before we get started, I'm just going to remind you of some information of triangles. This particular triangle is an acute triangle where all angles are acute. Over here to the right is an obtuse, where this is an obtuse which is going to be greater than 90, so this one has two acute and one obtuse. And then the one on the bottom is an oblique triangle where none of the angles is a right angle. Okay, and on this next page, we're going to classify our triangles based on the given information. I just kind of broke them apart into cases. So if you'll pause this for a few minutes and then jot those cases down, and then afterwards we're going to label some of these. Okay, so this first one, we have an angle, a side, and an angle. So which case is that going to be? Good, and that's just going to be case 1. This is a case 1 example, which is like an angle, side angle. Okay, and in the next one, we have a side, then we have an angle and an angle that's given. So that's also going to be an example of case 1. In this case, it was a side angle angle. All right, and let's move down here to this next one. We have a side, and an angle, which is going to looks like case 2. So two sides and the angle opposite one of them is known. So two sides and the angle that's opposite one of them is known. So this one's going to be case 2, which is a side angle representation. All right. Two sides and an angle that's included are known. So we got side, and then just a given angle. So this one is case 3, which is a side angle side, where the angle between the two sides are given. Okay, and the last one's the easiest one because it's a side, which is case 4. And so the law of sines that we're going to talk about today is used to solve triangles for which case 1 and case 2 hold. So these and these. So we're basically going to zone in on case 1 and case 2 when we're talking about our law of sines. And on the next page, we're going to write our theorem. Okay, so our law of sines is for a triangle with sides A, B, and C. The sides are always the lowercase, and opposite angles, which are capital letters, are for the angles, respectively. Our theorem is going to be the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. And usually we're working with 2 out of 3 of these, so selectively which ones fit our problem the best. And we'll work on that in just a minute. Now, just to quickly remind you, we said this theorem is going to apply to case 1 and case 2. So basically this one, and this case. So keep that in mind as we move forward. Also, another thing to note is angle A plus angle B plus angle C for a triangle, 3 angles. They're all supposed to total to what? For an entire triangle, 180 degrees. Good, so we'll keep that in mind as well. So when I said this, we're either going to use these two, or we may use these two together, or we could use sine of A over A with the sine of C over C. So we're going to use combinations of 2 of the 3 of those at a time when we're working with these. Okay, so let's look at our first example. It'll say solve the triangle. First of all, we look at what was given to us. We were given a side and we were given 2 angles. So we're just going to make a note. This is a side angle triangle. Okay. So we need to determine the value of A first of all. How can we do that? Well, we know all 3 of them add up to be what? 180 degrees. So I could say there's a lot of different ways to do this, but I can say A plus 60 plus 100 should equal 180 degrees total. Okay, and you can solve that. So what does A need to be? 20. Good. So I would just say A is equal to 20 degrees. Okay, so like I said, there's lots of ways to solve for A, so we'll make a note. Now we have that information. Alright, our next task is to figure out side A and side B, but we cannot use Pythagorean theorem because it's not a right triangle. Okay, so we have to use our laws of sines. Um, what we want to be able to do is we want to have one known side and one unknown side. So first of all, I can't work with the side A and the side B at the same time because then that would give me two unknowns. So let's do A and side C. Okay, so what I want to do is I'm going to use my law of sines and I'll say sine of A, angle A is over side A is equal to sine of C over C. Now the reason why we chose to work with A and C is because, like I said, we don't want two unknowns at the same time. So let's fill in this information. The sine of angle A, do we know the sine of angle A? Yes, we just found out what capital A was, and that was 20 degrees. Do we know what side A is? No, so let's just leave it lowercase a. Sine of C, well, if this is side C, this is angle C, so we will say sine of angle C, which is 100 degrees, over what is side C? 9. Good. So what we want to do is we want to be able to use our law of sines to have a relationship right there, a proportion that we have one unknown. Okay, so now we're just going to algebraically cross multiply and divide this thing. So we can cross multiply here, and that will give us 9 times the sine of 20 degrees is equal to A times the sine of 100 degrees. And what's our goal? To find A, right? Side A. So we want to get A by itself. How can I get A by itself? Divide both sides by the sine of 100 degrees. Okay, whatever you do to one side, you want to do to the other. Okay, and then this will cancel with this, and we will get that A is equal to approximately, if you put that in your calculator carefully, you should get 3.13 rounded in 2 decimal places. So that's side A. Okay, we have one more task at hand. We found this piece of information and we found this piece of information. What's left to find? Good. B. So first of all, I automatically know if I'm looking for B, I'm going to use this. Now my next thing is to determine which one I want to use. Do I want to use the one sine of A over A or sine of C over C? If I do this correctly, it shouldn't matter, but what's always the best option? Use something that was given to me in the original problem so it doesn't leave any chance of my own mistake. So let's do sine of C over C because both of those were given pieces of information. Alright, and we'll do the same thing here. Sine of B, what is our angle B? Absolutely. Sine of B is angle 60, and if you're not sure, it's opposite the side B. So angle B, side B. Over side B is what we're looking for. Sine of angle C, which was 100, over side C, which is 9. And once again, we're algebraically going to simplify. We will get 9 times the sine of 60 is equal to B times the sine of 100. Solve for B, so divide both sides by the side of 100, sine of 100. And then you will put that in your calculator, and we should get approximately 7.91 is the value of B.